today because things do change. In fact, this year is different a day or two ago. We'll always have read this first at the top and a Zoom summary at the bottom. So there will be two summaries in the end, as you can see here, because there are 2 days of the week. But obviously you don't have a Zoom summary for today, but you will later today. But this is a Zoom summary for Tuesday. And I would like you to take a look at that, even if you're here at the Zoom meeting, because I just summarize things and add a few things and so on. So it's worth doing that. And of course, before you do anything, you read this so that you can get an idea of what we're going to be doing. And there are two aspects of this this week, one of which we pretty much covered on Tuesday, but I still really want to review it. And that is solderless circuit board. How do you work with solderless circuit board? How do you get it going and building your first circuit? And we'll look at this one in just a moment. This is just a little mini solderless circuit board information sheet that I showed you the other day. So it's a solderless circuit board. And then the other is, of course, the solder practice kit that you should be working on now. This solder practice kit has a questionnaire at the end. This is the worksheet. I'll show you this in a few minutes when we get to it. I'd like you to turn that in by the end of the week. Whether or not you've done all the soldering by the end of the week is somewhat immaterial. Do what you feel is comfortable. And as I told you the other day, the whole purpose is to feel confidence and you know what you're doing when you're soldering. And if it takes another week or 2 or 3 to work your way through the whole exercise, that's fine. But I would like both sheets to come in. Okay, let's take a look at this. So this is the solderless circuit board. We saw a video on this on Tuesday. I would encourage you to look at that video again if you need to see how to put it all together. Here's the video. We talk about what the board is. Show you some board here. All this was in the video. I think it was a pretty good video. And this is a circuit you're to build. And this is a schematic drawing. They'll get more and more complicated as time goes on. This is a relatively simple one. But from this drawing, you should be able to construct the first circuit. Some of you have and have shown me pictures of it that you built, and that's great. I like that. But you should be able to do that. This is a symbol for a battery. It doesn't tell you how much or how many volts the battery has, but it's a symbol for the battery. You will be using a 9-volt battery, and you'll be using a little battery clip here like this, where red is positive and black is negative. You'll snap your battery into the clip. It can only go one way. You have a battery, and then you have 9 volts. And you will take the black lead here and put it on your board. And you will take the red lead here and put it on your board. And when you take the red lead and put it on your board, you will connect one end of a resistor to that red lead. And then the other end of the resistor to the anode end or the positive end of the diode. Make a connection here. You'll take the negative or black lead of the battery snap and connect it to the negative end of the LED. Doing that will complete the circuit. Current or electricity, which we'll talk more about soon enough, will flow around through the LED, through the resistor, and back to the positive. And if you build this circuit correctly, your LED should go on. And the video actually shows you this very circuit. It wasn't intended that way, but it does. So again, if you have any questions about that, do it. There are two or three things I want you to learn in building this, in constructing this. The first and most important is how the solderless circuit board works with those holes and how they're lined up and so forth. And you'll get it. I mean, you may make some mistakes. You may not get it lined up. excuse me, and so on, but you will get it. So learning how to do that's fine. If you get any LED to light, you've made considerable progress. You can replace this LED, pick any one you want, usually a red one, but it doesn't matter. Pick any one you want. And then if you've got it working, great, take it out and put another LED in, maybe a blue one or a green one or a yellow one or an orange one. In your packet that flashes. It's a flashing LED. It's an RGB flashing LED. It turns red, green, blue, and flashes at different rates. It's really kind of cool. It's clear. It's shown clear there. So find it, if you will, and stick it in there if you want. You know, and it'll be kind of cool. Now, a couple of mentioned, well, what about this resistor, and do I have the right values? And all I'm asking you to do here is to start out with a low value resistor, like 150 ohms, or around there, 100 ohms. If you have 100 ohms, if you have 120 ohms or 220 ohms, you stick it in there to start with and see how bright the LED is. And from then on, I want you to replace that resistor with larger values of resistors, going all the way up to the maximum. I don't think you have 0.3 meg. I don't think you have one, but that's okay. I think you have 100K. Get it to the higher values here, and see what happens to the LED. The LED is an indicator. It indicates the amount of current flowing in the circuit by the brightness of the LED. So a brighter LED means more electricity or current is flowing. A dimmer LED means less current is flowing. And current and resistance, as we will discover, are inversely proportional, meaning the higher the value of the resistor, the less current that flows, and thus the dimmer the LED. The lower the value of the resistor, the more current that flows, and the brighter the LED. And down here at these low values, like 100 ohms, 70 ohms, the LED will light, and you'll see, you should probably see a little difference here. As you get higher, up into 100K and so on, you will have so much resistance and thus so little current that your LED won't even light. So that's what I want you to do as well. I want you, hang on just one sec. I want you to build the circuit so it works. If you get it working, meaning the LED is lit, and you've got that resistor in there, you need to have some resistance in there. You're 90% there. Then change the value of the resistors, increase them to reduce the current and reduce the brightness. Question. Anybody have a question about that?
Yes, I have a question, Professor.
Sure.
How are we gonna send you the homework
After this.
on that specific project?
How are you going to send me that you built it and so on?
Yes.
You don't have to. Okay. You don't have to. You do have to. Hang on just a second. In this particular case, I'm asking you just to do this. Send in the sheet, the worksheet. Put your name and date on it. You'll get 25 points. Procedures. Just I put that here, write up something at the bottom here. Tell me it worked. And yes, indeed, the more resistance, the dimmer the LED. A couple of you have done this already and sent me a picture of your LED that's lit up. If you want to do that, that's fine. I'm not requiring it. I'm not requiring it. It's kind of cool. I really like that, but don't stress over that. If, you know, okay. Does that answer your question? You know, just
yes, thank you.
Just do this exercise, and that's going to be true with a number of things. I'm just going to assume you want to do these things, and you know, it's true at the con. You know, we did it in person. I'd walk around and I'd look at it. And in fact, I'd even stamp the sheet. I give you a little stamp with. I've got it here somewhere, my own stamp, and I go, you know, with my name on it, proves you've done it. But we're not there now. We can't do that. So, but do turn the sheet in. Okay, good. Are there any other questions about this? I think somebody wrote to me. Well, somebody wrote to me this morning and bought a larger board with 400 holes. That's halfway board, it'll work. It'll be fine for anything you do here. Most of the boards that you would want to order are 800 holes and so on. And again, we don't need, get that as soon as you can, but you'll be all right with a little mini board that you've got. Again, look at the video. This video is good that covers the bases that I wanted to cover, and it has a circuit built into it that we're building, and it shows you some of the things that can go wrong and alignment if you just don't line up the right hole there and that sort of thing. But it sounds like you guys are okay with this. Okay. All right, no question. Let me get here. Okay, how many? We got 26 is good. That's good. Let me show you a little project here. I'd like to try to show you something every day. This kind of washes out a little bit. This is an example of how amazing electronics is in the sense that it costs so little to do so much. This is a pretty sophisticated clock. It shows you the time of day, the temperature in centigrade. It tells you the date and the month and the year. And it has these LEDs, 60 of them, blasting around here with 10 different patterns that you can come up with by just pressing the button back here. And this one I built. This one uses both surface mount components, soldered components, and through-hole components. And it was a challenge. But the truth of the matter is you can buy this as a kit in which you put it together, just a few pieces together. You can buy that for less than $10. Less than $10. Today, when we talk about soldering, you're going to do some soldering. You have a choice. So basically, you will do soldering that is through hole or surface mount. You're not going to do surface mount now. We've done it in the class in the past, but I don't know if we'll ever do it in this class. It doesn't matter. Surface mount, through hole is what I've got right here. And this is what you have on your own printed circuit board. You stick the leads of your components through holes and solder on the other side. This is surface mount.
So when do you have
where you solder on the top?
When do you have Jason?
And this is a challenge, real challenge. But I just want to show you the difference between those. Okay. Okay, now. Let's see. You have the solder practice kit we're working on. Added here 2 solder videos. I put these on yesterday, I think, or the day before yesterday. And we're going to look at both of them now because they're really very good, I think. The first one is 10 minutes that we're going to look at. The second one is 5 minutes. And when you look at this, you're going to be a little surprised, I think. There's a very interesting young lady who is kind of goofy. I think that's her modus operandi. But she covers all the bases. She covers all the soldering bases. And so we're going to look at this together. I'll stop it a few times, not many times. And it really gives you a lot of good information.
Still in the FBI, the people I interview, the men and women.
Well, if you can mute that. This one's 5 minutes long, and this one, I love this one because it's exactly the kind of soldering I want you to do. It shows you exactly the 4 steps and exactly how I want it done. So we'll look at that too. But let's take a look at this one and enjoy it. But there's a lot of good information from her on this, as you will see.
Build your brand online
And she
with
is.
the beautiful logo. Just go to Wix logo.
Usually we're beauty in the bowl. Today we're gonna be beauty in the bowl because we're gonna be having the solder, which is the hottest engineering skill. You pick up the people that you're attracted to at the bar with your soldering skill.
So you can see already what she's kind of goofy. Very, very nice. And the dress is, look at the printed circuit board patterns on the dress. But anyway, let's get started.
Maybe because we're gonna have to draft this session.
All you need is solder, soldering iron, and something to solder. So like a piece of wire. The burn is through, so I'm gonna flip on my sun. I like to keep my sun iron at 600 degrees Fahrenheit because I'm American. Definitely don't touch the tip, but if you do, immediately run your finger under cold water and apply whatever weird herbal medicine your mom believes in. A really common mistake that people make is when the solder isn't working or when things aren't going right, they jack up the heat on the soldering iron. That's the last thing you want to do. You want to turn the heat down. You really don't want to run it too high or you'll start burning things off of your boards. A good tip for soldering header pins on, when you order sensors or anything, they'll usually come as just a board with holes in them and then header pins. And you have to know how to solder them on without going crooked.
So you can see she talks so fast, and she's soldered a circuit board. She puts the IC in there, and then she puts the solder board.
A solderless breadboard like this. So you put the header pins in the breadboard, and then you can put your perf board on like so.
It's that perf board. You don't want to confuse this with solderless circuit board. Over the years, some students have brought this into class and said, "Is this what you wanted, Mr. Reese?" I said, "No, it's really not. It has its purpose, but you want the clear board, the board down here that we talked about."
And so now you can see you've got the header pin sticking through the perf board. It's all flat. It's all pretty. It's all beautiful. I don't have solder. Andrew, can you get me solder? Oh, options. Thank you. Rosin core solder. You and that row.
All right, she's using core solder. There's what's acid core solder for soldering sheet metal. You don't want any of it in your shop or anything like that, and you won't get it. Rosin core solder is solder that has rosin inside. It's actually inside, and it works very well. There are two kinds of basic solders, though. One is lead-free, and one is has lead in it. You have both. In your kit, you were given lead-free solder, and I gave you some extra leaded solder.
Rojas approved stuff. So we're gonna take our Rojas approved solder because Andrew's a goody two shoes. Perfect. My soldering iron just heated up. So the first thing I want to do when I get this is tin the tip of the iron. I'm going to do that by just pushing it against the solder and it disappears.
So that's called tip, and you want the tip of your soldering iron to always be coated with solder. So from time to time, quite frequently, you just clean it off with a sponge and then put some solder on it. You want solder on the tip. You want it to be tinned.
You know, I got that glob of solder, and I'm just gonna throw that in our steel bowl. And but that gives you a nice, clean, non-oxidized tip for soldering. Solder flows to where it's hottest. So wherever on your part is the hottest is where your solder is going to be, which means that if you're only putting heat on the pin or on the solder or on the board, that's the only place the solder is going to go. So, and then the other thing is that heat through surface area. So the more surface area you have against an object, then the more heat is going to go into that object. So
the key here is that you're always soldering two things together, two elements together, two surfaces together. In the case of your printed circuit board, one of the elements is the pad. The other element is the wire or the lead sticking up. You want to get heat on both of them. And the second video that we'll look at will emphasize that.
Key
more.
is that you want to get an equal amount of surface area between the soldering iron tip, the pin, and the little copper circle on the board. So to that, I'm just gonna wrap around. I'm gonna tap the soldering iron on both and make sure. So I've got a pretty even amount, and then add solder in.
And what she did, that was a good solder connection. Notice she came in from the side with the solder, the other side, and notice she removed the solder and then waited, not very long in this case, to remove the iron, instead of removing both the solder and the iron at the same time.
And there you've got a nice joint. And you want to get that nice little pyramid. And so, show you again. Angle is really difficult to solder. And always be sure to be cleaning your tip frequently. It's kind of like painting, you want to make sure that your brush is always clean and has enough pigment on it. Keep in mind it's okay to start by putting your iron on the thing and letting it heat up a bit before you go in.
Yeah, this is right. You apply the heat and wait a second or wait a long second before you get in there with the solder. The whole thing should take about 4 or 5 seconds.
Add your solder because then it'll flow much more nicely.
She's doing a good job.
I'm ready to go and I can lift my beautiful thing off and you'll see these header pins. They're nice and straight. I want to show off my dress. I should do like a full fashion show because this dress is baller. Go all out with the, you know.
Are you ready for this? It's cute though.
So another thing we're going to learn is how to desolder. So say you soldered something on and then you screwed it up and now you have to take it off. So my number one way to desolder is I like solder wick. This is just a braid of really thin copper and you can pull it apart here so that you can see. Think of it.
Okay, you have this in your kit. You don't have a tube of it like is shown there. You just have and you're best in your exercise or activity to do some desoldering, and that's important. And one way to desolder is with this braid here. Okay. Now let's watch her do it, and then I'll explain something.
A bit like a sponge for solder. You know, it's got a bunch of holes in it, and the solder can flow up the wick. Maybe I'm feeling like this connection should have been made. I'm just gonna hold that on there and really press the soldering iron into it.
See the solder coming up?
The solder wick is filling up, so you can see that's got a ton of solder.
And then you cut that off and move it again.
Don't forget to really get in there with soldering iron.
Now, notice she's holding the plastic piece. You don't have that. You again have just this strip here. Don't hold it in your hand and put it down there. You'll only do that once because the heat will go right up and burn your fingers. So you have to hold it with a pliers or something like that. Normally it comes as a tube, but you don't have that.
And now we've got a slightly more silver eye, except you've removed your mistake. Good job. All right, so the next thing we're going to learn how to do is splice 2 wires together. Don't count on your solder to be the structural integrity of joint. Do solder to be sound at all. This is actually kind of the difference between thing is that melt your work. It only, which is why it cannot be function any. Whereas weld is when you melt your work pieces slightly as well, and then the workpiece and the filler material are melted together to create.
It's interesting because throughout the world, other than in the United States and most of Europe and in China and so on, when you get instructions for your stuff to build and all that, it will use the word weld. It will not use the word solder. It will use the word weld. But she's right. There's a difference between welding and soldering. And welding is a fusing of the action with the metal, the pieces together. Soldering is not. So as she says, she's correct. Don't use the solder to hold the joint together physically.
A mechanical joint.
Okay.
Did nobody else find that interesting? I think that's super cool. These are by far my favorite tool, probably on the planet. I was expecting to get a pair for my birthday, and I didn't, and I'm still bitter. That's why we broke up. If you don't have really expensive, really fancy pair of wire strippers, you can be like the plebeians, like myself. Those were borrowed. And with a normal pair of wire strippers. What I like to do is think about that much, and then cross them and twist. So we're gonna twist this bebes together, and then take your solder. So I'm gonna tin my tip.
You don't just solder on printed circuit boards. Notice she's always tinning it, which is good, which is what you want to do. I'll be sending you more solder. I didn't send you enough. I sent you enough for now, but in the next round of sending you stuff, I'll send you
this
solder.
is something called heat shrink, and it's basically tubing that shrinks as you heat it up. So I'm going to slide that on like such. Cool. So then this is a heat dryer. This is a hot air gun. I basically turn it on, and it starts producing hot air. And as you point it at something like this, turn it like a little rotisserie chicken. And we're good. See how quick and easy what that was? So that's if you have solid gauge wire. If you have stranded gauge wire, ball game. Again, we're gonna strip the wire. The thicker the wire you have, the more you want to strip down. So that's.
She has a very fancy stripper there, a wire stripper. You don't need that kind of thing, but whatever.
Even I would say not quite enough. I'm gonna strip a little bit more. So again with the twisting, but what I like to do is actually kind of fan it out and break it in two like this, and take those two, kind of link them, a diamond, and then twist. So this is a pretty solid joint. There's a lot of wires tangled together there. That's fine. If I were doing a lot of these, I would definitely switch to a bigger tip. Get my solder on there, clean it off, get a nice big glob of solder to tin this, and then.
She's always tinning, which is what you should do too.
You'll notice I'm laying the side of the iron against the wire, and that's just to allow more surface area for heat to flow. And just pushing my solder in. When I hit the end of my solder, be sure to throw it in your solder waste container and put that in electronics waste, because high chance it will have leaded material in it. So now that you can see the solder is really fused throughout a lot of wire, so a lot of solder, but there you go. Put your nub, solder waste, not the trash can. Do not put solder in the trash, put it in solder waste. Thank you. The baby seals will thank you, as will pretty much all the animals living in the dumpster landfill. You know when they like build parks on top of the landfill? Those animals. Future animals, or when you live on top of a landfill, you'll thank yourself. Since I did heat shrink on the last one, I'll use electrical tape this time. I'm gonna take some electrical tape and snip, snip, snip. The thing with electrical tape is it's stretchy. Take advantage of that. You can get a nice tight job by pulling on to wrap it around. And obviously that's a little bit messier than the heat shrink, but it's definitely insulative. It definitely works, and that's also not going anywhere. Beautiful. Now that I've made a mess, be sure to periodically go through, throw your things in solder waste. And here is my solder waste. Soldering shouldn't cost you a whole lot of money. I mean, like a $30 welder, you can get it on Amazon or Radio Shack. If you can find a Radio Shack that still exists, is perfect. And when you're done with your project, it is super critical. Turn your soldering iron off. You do not want to burn your house down because you've like left your soldering iron on. It's like leaving your stove on. Like nothing probably will go wrong, but you might give your cat a really bad surprise.
Well, that, huh? Any thoughts on it? Let me get rid of this. I get these space things. So any input on from that? No? Maria, anybody?
No, I mean, I had done some soldering, you know, conductors together, but I think I wasn't using the best technique. I would just kind of tin the wires and lay them right next to each other and then add solder and make the connection. But
okay.
I see how she fanned it out and, you know, kind of intertwined them. So I can try that now.
You always learn something more here. I mean, I learned something from watching this video. There's always something new. Anyway, again, you can look at it again. Okay, let's look at this NECA one though. This is only about 5 minutes, but as I said, I like this one because, well, you'll see. You'll see.
This video shows basic soldering technique and the equipment used to solder.
No, I don't, we'll come back to that in just, well, in just a second. Notice how he removes the solder but still keeps the iron there.
Soldering technique and the equipment used to solder.
See? And then removes it.
There are two main types of soldering iron. The iron to the right has a station which shows temperature on the display. The controls adjust the desired target temperature. The one on the left works at a fixed temperature but is used in the same way. If you are using a digital iron, then set the target temperature to around 350 degrees C and wait for the iron to heat up.
That's centigrade, of course.
When you're not soldering, remember to keep the iron in the holder. Be careful when you're soldering not to put the iron in contact with the lead. Some soldering irons have PVC coated leads which will melt through easily and pose a risk of electric shock if touched. The best leads to use are made from silicon, which won't melt at the temperatures soldering irons reach. The other item you'll need is, of course, solder. Solder is a low melting point alloy which slows easily when heated to liquid state. When it cools and solidifies, it fuses to the surface of a metal at the molecular.
You see, again, notice that he's putting the soldering iron on the two elements that need to be soldered. The basic idea is to put it on the pad and then bump it up against the lead. And that's exactly what he's doing.
The level, providing good electrical conductivity between two metal surfaces. Solder normally contains flux, which helps the solder to flow and also helps make a good contact by removing.
The flux will come out. It looks like varnish and so on. You'll see it on your boards. It's good, not bad. Don't bother to try to clean it off or anything like that. But if you see this, you know, brownish liquid coming out there, it's good. That's the flux.
Oxides on the surface of the metals being joined. Although modern flux is not toxic, when soldering you should always use a fume extractor to prevent the fumes from the flux irritating your lungs. The fumes are extracted by a high efficiency particulate air filter or HEPA filter before the air is returned to the room. Before you handle the components, it's strongly advised that you wear an earthing band to prevent electrostatic damage to the components.
So you're not going to have one. I don't have one. Really vent, you know, open the windows, that kind of thing. Okay. And this strap, well, that's something we can talk about later, but nothing for you to concern yourself with right now.
You wear an earthing band to prevent electrostatic damage to the components. There are two different soldering types, surface mount and through hole. Surface mount connections are made by heating components with pre-applied solder in an oven so that it melts and joins through the surface of the board.
It's possible to do this with your soldering iron and with smaller solder and so on. Back to articles of electronics back 1994 and 95 was on surface mount. How hobbyists can use it, surface mount, and do it. But we'll be concentrating on through hole.
For this tutorial, we'll look at plated through hole soldering, which is done on boards with printed circuits on both sides.
Now, this is a double-sided printed circuit board. You don't have that. You have a single-sided circuit board,
which is done on boards with printed,
which is pretty easy for you to determine which is the component side and the solder side. This one has plated through holes because there are traces on both sides. So the component side, put the component here and solder on the back. This is the way it's set up. The truth is that almost all boards are at least two-sided like this, and the actual soldering is easier on a board like this. But
circuits on both sides. Through-hole soldering is when components are pushed through a hole in the board and soldered from the other side. The solder flows through the hole to make the best possible contact. First, take your component and create a bend in the legs with a pair of pliers, so that each leg is at a right angle. Push the legs through the holes in the board at the appropriate place and push it all the way down. Then turn the board over and bend the legs slightly to lock components in place. When the iron is at temperature, first clip the iron on the wet sponge on the iron holder to remove any excess solder and flux residue might be there.
And you'll be doing that a lot. Don't overdo it and cool it down. But I mean, every time you solder, every 4 or 5 times you solder, you'll just want to automatically just clean it off again because it will corrode.
You then apply heat directly to the pad for about a second before placing the solder in contact with the pad. When the solder starts to melt, feed it in for about a second. Take the solder away, but leave the iron on the pad for another second. Then take the iron away and let the connection cool.
So that's it. That's, this video's worth it. Just wait a second after you remove the solder to then remove the heat.
Let's have another look at that.
Good, John.
Before you make another connection, it's important to remove any excess solder remaining on the tip of the iron. This is because any flux in the solder will vaporize until there's none remaining. If you try to make a connection with solder without any flux in it, you risk making a bad connection. When you turn the board over, you should see that the solder has flowed through the hole by capillary action.
Now, this is true with double-sided printed circuit boards. With your board that you're going to be doing here, only single-sided. Don't expect it to come through the other side. You don't really want it to come through the component side. You just want it to be on one side.
Teeing a good contact. Trim the leads just above the solder using some wire cutters.
When you do that, yes, cut the leads off. And basically, when you solder on a board, the idea is to put some components in, maybe 4 or 5 or 6, solder them, cut the leads off, and then add some others. You don't want to stuff the board entirely with all the components that you have and then start soldering, because it'll be too crowded with all those leads sticking up. So you want to get rid of those. However, when it comes to integrated circuits and you put them in the board, you don't clip off the pins. They're short enough and you don't have to clip them off.
When you cut the wires, be careful that the cut end is held captive so that it doesn't fly off. And by putting on when cutting, if you make a bad to the component, remove the solder by using a desoldering pump.
So there are basically 2 ways to desolder. One is to use the wick, which we saw earlier, and the other is to use this pump, which has a Teflon tip, and you heat it, as you'll see, and pump out. Either one. These are relatively inexpensive, and most technicians will have both of them, and will use one when they feel it's appropriate, and then use another the other one when it feels appropriate. So it's not one or the other. It's just to have them around.
This is a spring-loaded piston with a trigger, which when released creates a vacuum which sucks the solder up. Cock the pump and to melt the connection tip of the pump onto the melted solder, then release the trigger. You might have to repeat the operation several times to clear all of the solder.
It works though.
Ideal solder should look like a cone with slightly concave sides, showing that the solder has flowed through the hole.
You don't want it to be gray and balled up. If it is, reheat it. Usually what happens with gray and balled up solder joints is that you haven't heated both the surfaces. You've only applied heat to one.
You see all the solders here look regular. Bad joints are noticeably different to the concave cones of good joints.
See there, look at one here.
If your joint looks like any of these, then it'd be wise to remake it. Bad joints can lead to intermittent connections or no connection at all.
Okay, so let's get out of here. Okay. Any question about that or any thoughts? You can watch only so many of these videos and you say, God, I want to do it. I want to do it. And again, you're practicing. It's not do or die. It's not a tiny little project that has to work. Okay. Okay, so let's see. Okay, so are there any questions about what we've covered today and what to do? And are there any questions? I see, silence. I don't hear anything.
Mr. Reese, for the 9-volt LED circuit,
Yes.
I was looking through the resistors and I don't have the exact values. I don't think so, like the mega ohm resistors and stuff like that. So I guess the concept is just to increase the resistance, right? And we can use whatever resistors will do that. Is that okay?
Exactly.
Okay.
That's exactly what I want you to do. So why didn't I put the quote right values in there? I don't know. That was a list I came up with that you will need, but you've hit the nail on the head. That's exactly what I want you to do. Start with the lowest value you've got there and work your way up and see, again, that resistance is inversely proportional to current and thus brightness. And as you add more resistance, you should get dimmer and dimmer. And if you have something like 100K, 100,000 ohms in there, it'll be so high. That's high enough that I doubt the LED probably won't even light. So again, there's two main, well, one, you're learning, two, you're learning how the solderless circuit board works. That's the key. And number three, you're learning that there's a inverse relationship between current and voltage. Yeah, good. Any other question? Anything else? Anybody else? Okay, so well, you have a fair amount to do now. Again, I will get the solder board one finished. Build that little circuit. Change the LED. Maybe find the flashing LED if you'd like. Practice your soldering. Answer those solder questions. I want these 2 sheets turned in this week. And read the summary. There'll be a summary today. They'll come in later today for this. And then we'll be ready to move on to, I'll publish this now. So you'll see this, you get an idea of where we're going to go next week. We're going to look at the big 3, current, voltage, and resistance, and you'll have exercises for all 3 of those. And then you're going to have you're going to work with your meter, and you have a complete, rather detailed exercise on how to use your multimeter here. And you have this stuff, and you'll go through and you'll measure current and voltage, you'll measure current, you'll measure resistance, you'll check out diodes, you'll check out transistors. It's, I think it's a nice activity. And I think you'll do that. That's your main hands-on activity next week, and it's important and thorough, I think. This is the theory. These 3 things are the theory, and so on. So I published that. You can take a look at that. All right. Are there any questions? Further questions? 25 of you showed up. I'm really pleased with that. I know some of you can't show up because you're just not. You're not working. I mean, you're working and whatever. But I'm still missing a few students. We'll see what happens after the 3rd week. If I haven't heard from 4 or 5 or 6 students, I don't know. I'm not going to drop them. I'm in no hurry to drop anybody. But watch for announcement. And if there aren't any other questions, I guess we're kind of through for today. Give you some time to work on stuff. Any thoughts? Any questions?
Yes, Professor.
Okay. You should have what you, whoops. All right, okay, then I'm going to stop sharing here for a moment. We don't really need that. There's Anastasia. Look at all of you. That's good. Chat, let's see. What type of soldering iron should you be getting? You get one that's somewhere between 30 and 40 watts, not critical. Get a little higher, get a little lower, you'll be all right. You don't need one that changes its temperature. You can buy a soldering iron for around $5 or $6. A better one would be $10 or $12. The main thing is to have a nice conical tip. That would be nice again. There was a time when I would talk to students about soldering irons and the student would bring in a gun, a soldering gun. These are old-fashioned guns for vacuum tubes, working with vacuum tubes and large solder connections. I don't even think they sell them anymore. I guess what I'm saying is you really can't go wrong when you just get anything and it'll work, I'm sure. Anything else? Okay, I'm going to bow out. Get me those sheets turned in and have a nice day and have a nice weekend.
I will.
Thank you.
Keep
Thank
those
you.
out. Keep your electrons flowing.
Thank you.
Thank you so much.
All right, you're welcome.
Thank you.
Thank you, Professor.
You're welcome.
Professor Reese.
Yes.
Oh
Edgar?
yeah, and I practiced soldering. It's just wow.
Did you build
it's
that?
so
Did you make
hard.
that whole thing with your soldering iron? Wow. Go ahead.
No, it's just soldering. Practice soldering is not easy. I probably used my wrong hand. Normally, I should solder with my right hand.
Well, you should put the iron in your right. If you're right-handed, you put the iron in your right hand. Solder in your left hand. Are you right-handed?
Yeah, I am always right with my.
Well,
I always write with this hand.
yeah. So hold the iron in that hand.
Yeah.
Have you got a soldering iron right in front of you there? Again, I love your background. Let me see you again. Hold your
This
soldering iron.
iron.
Yeah, well, get it out of that bag. Hell, it won't work in that bag.
No, I know. I just.
Yeah, get it out of there.
Yeah.
And you hold solder in the left hand and look at the videos. And again, don't panic. You don't have anything to build there that needs to work right now. Just
No. You just say, practice this and take your time.
well, read the instructions. It tells you what steps to take. One of them has a lot of wire for you to solder on at the front there, but you don't have to solder it all. Just solder a few pieces.
Yeah, and I kind of put the soldering iron a little bit too high.
Well, you can get too high, but you don't want it to be too low either because you have to spend more time there on the pad. It's a trade-off. If it's too hot, it could burn the pads off. If it's too cool, you'll keep the iron there too long and you'll cause trouble.
When do we finish the soldering kit thing? This week or next week?
A couple weeks. Go ahead. Take your time.
Yeah, I just take my time.
No, take your time. Again, try to remember what I said about what I did up until now. I would give 1 day of practice in solder in the class where they get a little board and they'd solder some resistors on it, then maybe an integrated circuit. You're getting so much more this time because I had them available. In fact, I walked in their drawer and said, oh my God, I forgot about these. And I had 50 of them. So I said, I'm going to give it to my EL1, EL2 students. So you're getting a lot more and you're learning about components and so on and so forth. So this will take a few weeks.
Yeah, did you heard of, Ohm's law was based by a German physicist. Yeah, and I don't know, the Germans call him Georg.
So, yeah.
That's what the Germans will call him that way because that's how they say it. It means George.
See, you always learn something new every day. Okay, we'll get to Ohm's law too, but not right now.
Yeah, I know.
All right, Ryan, anything else?
Nope.
All right, well, heat up that iron and
And
practice.
when do we finish the soldering board by like 2 weeks?
Yeah. Yeah. I want you to do the worksheet. I want you to answer those questions this week and turn it in.
Yeah,
And then just keep practicing your soldering until you feel comfortable with it. And then maybe put it aside for a while and go back to it a little later if you want. I'm not collecting it. I'm not seeing it. Can't do that here now. I mean, if we were in person, I would. So I'll never see it unless you want to take a picture of it. So don't stress out about it. Just practice soldering until you feel good about it. Now, in a few weeks, you'll get another project. Well, actually, you have it already. It was sent to you, in which you will, be asked to build a project using your soldering and using your soldering techniques that you've worked with. Okay. All right. I'm gonna bow out.
Thank you so much.